Good morning, everyone. This is the lesson for April 3rd, and this is going to be a different lesson because Mrs. Lamb is going to attempt to teach this lesson by video standing up because all the other ones I've been sitting. And so if I disappear from screen, it means I'm either my rolly cart got away from me or I actually fell down. So just enjoy and hopefully don't post this to anything weird or do some type of weird TikTok with music behind it if I fall. But as long as I don't see it, I probably wouldn't know, right? So let's get started. Today's lesson is going to be from 8.4 from your book. But before you go to 8.4, I want you to turn all the way back to 5.7, which is on page 222 in your book. And if you look, once you get there, flip to 5.7, it's graphing absolute value functions because this is something you've already done and it's going to be something very similar to what you're doing today. So let me step back and show you what we've got here. So if I'm translating absolute value functions, if you remember what a translation is, a translation of a graph is either shifting it up and down or it's shifting it right to left. So that's what a translation is doing. And if we look at what our absolute value function did way back in 5.7, and as I recall, you all did pretty well on this because, you like to draw, I suppose. But what happened is if I just had the absolute value symbol and that was it, then my vertex would be right at 0, at 0, 0, right at the origin of your graph. But if outside my absolute value with x, if I added 2 to it, it shifted my graph up. If I subtracted 2, it shifted my graph down. So this was basically telling me, hey, absolute value functions make a. Yeah, I've already got stuff all over me. You know how that goes. You all noticed that. Which reminds me, if I end up looking like a dictator from history because I've rubbed my upper lip, just enjoy. So let's go and look at this. So basically, an absolute value function made a V for victory or peace. And when I added 2 to it, it told me, hey, move your V up 2 places. If I subtracted 2 from it, it said, hey, move your V down 2 places. Now look what happens here. If I put what I'm adding or subtracting inside those absolute value symbols, if I'm actually doing it 2x inside, then that translation is shifting it left to right. Where if you look at this is saying go up or down. This one's saying go left and right. So this one told me to shift it to the right 2 places. This one told me to shift it to the left 2 places, right? I'm kind of looking. As soon as I said that, I totally forgot what I was saying because I was thinking it did it opposite. Yeah, I think it goes opposite that way. So check out 5.7. Don't worry, we're getting into it more in the next section. So let me erase this. Just remember, if it looks like this, I'm shifting it up and down. If it looks like this, I'm shifting it left to right. And a translation, when it says to look at the translation, then that's basically me figuring out how did it shift up and how did it shift to the right and left. So when you're trying to figure out a translation, I'm talking about how did it go, how did it move up or down, how many places, and how many places did it shift right to left. Because on your test, on your quiz, you're going to have these things that ask you, all right, what's the translation of this graph? And before you totally freak out and say, I don't know, a translation simply means my graph is moving. It could be moving up and down. It could be moving right to left. It could be doing both, because that's most of the time what we deal with, that's what's happening. And it's important for you to learn that, even though you've got these fancy graphing calculators, you don't want to take the time to plug this formula in so you can see how the graph is going, graph is going. You want to be able to just look at the equation and say, oh, it's doing this. It's moving left, it's moving right, it's moving up, it's moving down. So that was absolute value functions. We're still doing translations. Now I'm moving this way. I'm swapping to my other book because my book is in two different pieces. And if you'll turn to 8.4, 8.4 is on page 344. And we're going to start looking at translating power functions. I'm going to shift over here where I've written some stuff. Hopefully it's not too glary for you. Let me try to shift. Yeah, you got the wonderful intake over here. So let's look at shifting translating power functions. So if you remember, this is something we've already done. You've already graphed a little bit. Whenever you had something squared, kept moving out. Whenever you have something squared in an equation, you've already done a graph that looked like this, and it made this cool looking shape that was called a parabola. I totally misspelled that. All right, there, make that an A. Parabola, there we go. Parabola, which is basically this curve. If I just had y equals x squared, my origin, my vertex was at my origin, 0, 0, and then I just picked me some points, made me a cool looking table, got me a few points, and I made this nifty looking parabola. Then what we're doing today is we're actually going to start translating that parabola. And if you look at what we're doing, if I've got x squared, that's telling me, hey, it's going to be a parabola. And this is telling me to shift that up 2 places. Plus 2 is telling me go up 2 places. And then if I've got a -3, it's saying go down 3 places. So what I'm doing today is I'm going to try to explain everything, and then we're going to try to do all these things in your homework so we can attempt to figure out this stuff together. Now there's one other thing that I've not written down that we're just going to have to go through. So let's look in your book for a second, and let's just look at what we did. Example 1 is basically what this is telling you. If I just have x squared and I'm graphing it, that's my origin, the translation, it just starts right at the origin. It's not translated, and it's not that big of a deal. If you go to example 2, it's showing you this right here. It's showing you that that's shifting my parabola, no longer a victory. Remember, that was absolute value symbols, made that. But that parabola is shifting up or it's shifting down. So we already talked about what a translation is. Now, let's go over to page 346. 346. And let's look at graphing. What happens to a graph when I'm doing something to x in parentheses? It's very similar to what happened to the absolute value function. So let's erase some stuff. I didn't get all this down. So I haven't fallen, I'm erasing. Moving over here, I'm going to do some translation functions. I want you to look at example 3, and let's look at actually what is happening. Then they've given you a nifty little table that you can just use for your test, use for your quiz. You can look at all these things and be able to figure it out, and because remember, everything's open book now. So let's look at example 3. So if you look at example 3, if I've got a function that looks like that, and I'm talking about how it's shifting right, left, or whatever, that's just telling me that one's staying right there at the origin, right at 0, 0. That's the vertex of my parabola. Now let's look at your next one that you've got on example 3. So what they're doing here is I still have the x squared, X squared is telling me, hey, still going to be a parabola. And then inside here, you've got a negative 2. This was the one that's very similar to what we did with absolute value symbols. And the absolute value symbol, it says negative 2, and you think, oh, negative, I'm going to go down. But when you're translating something to inside parentheses or inside absolute value symbols, you're not going down to, you're doing the opposite. Why is it like that? I don't know. When you get to heaven, we can ask God what happened. But we are going up. That's basically telling me, not up or down. What am I saying? We're going to go to the right 2 places. So we're going to the right 2 places. And I'm looking right at your example right there. And I totally wrote that wrong. It should look like this. There you go. That's what it should look like. So if I've got x minus 2, and that whole function is squared, that's basically this is telling me, go right 2 places. This is what happens when you try to teach on video and you've not written everything out. But oh well. Let's look at your example, your next example. Your next example is just y equals x plus 3, and that function is being squared, or that little expression is being squared, however you want to talk about that. Parenthetical expression. Okay, so since a negative 2 is telling me to move to the right 2 places, which is almost conversely opposite of what you're thinking, but this is why it's happening like this, guys. If you think about it, if I've got, that's basically telling me, hey, that is a negative 2 and a negative 2, and it's shifting it over. Because if I'm squaring 2 negatives, it's becoming positive. Or if you just want to say, you know what? Of course, then you're going to get confused with this one. That's just how it ends up shifting. This one is going to shift to the left 3 places. And once again, it's one of those things. It's just one of those things that be. You can't really question it. You just say, okay, that's just how it's shifting one way or the other, and just moving on with life. So look at example 3. You can read through that if you've got any additional questions. I really like the little tables they give you. So if you've got a vertical translation, they show you how it's basically something's being shifted up and down. That's what we did over here. So a vertical translation looks like this. It's moving up or it's moving down. And then this type of translation is shifting left to right when you've got something like that. But in a perfect world, or you would only have to deal with one translation, but that's not how we're going to be. I have the most terrible blue pen. I'm going to swap to a black one. What normally happens with most parabolas is what you've got down here at the very bottom of page 346. And that's where you not only shift up and down, but you also shift right to left. And that's what you can kind of see up here at the very top page of 347 in this cool little table. So if you notice, they've given you 2 examples. I'm going to write those out. You can look at your book as well. So let's look, and this is telling you exactly what to do. What is this telling me to do? Well, this is telling me I need to move up 4 places, right? And this is telling me I need to shift to the right. It's the opposite. I need to shift to the right 2 places. This is also telling me something about my parabola. It's telling me what the vertex of my parabola is. So if there's something if it's asking you for a translation, so if it's asking for the translation, then I would write out, okay, it is moving up 4 places, and it's shifting to the right 2 places. But if you look at the end of that graph, it's asking for a vertex. And on your quiz, that's what it's happening on a quiz and on your test that you're going to end up probably with next week. I'm giving you your quiz in your packet on Monday, and you'll probably have a quiz for 5.6, and I'm just going to go ahead and give you your test for chapter 8 as well, because it's a fairly short chapter, and just give you some time to work on it. So on your quiz and your test, you're going to have something that looks like that. They're not going to ask for the translation. They're asking for the vertex. Well, think about my vertex is going to be an X and a Y. And think about X's and Y's and what it does. X is, if you look over, well, I don't know if you needed to know that. But really, if you remember with X, you're going on, that's my X axis, and I'm shifting to the right and to the left, right? This is my y-axis, and I'm going up or I'm going down. So when I'm trying to find the vertex, I'm going to look at this, and I'm going to say, all right, which one's telling me to shift right to left? And that's telling me to go a positive 2 places. Which one's telling me to go up or down? That's this one right here. It's telling me to go up 4 places. Does this kind of seem familiar a little bit to you? Maybe, maybe not. If you look at the next one, it's just where both of them swap. We'll do that one too, just to kind of get it in your brain. Did I just knock into that? I'm getting really too close to you, so let me move that back a little bit. So let's look at your next example. You've got y equals x plus 3, that whole little expression squared, and then we have a negative 2. So let's see. If it asked me for the translation, what would I say? My translation would say, that's telling me to go down 2 places. This is the opposite. You want to say, oh, that'd be the right. No, but it's wrong. That's telling me to go to the left 3 places. Down. Did I actually do this? Okay. Down 2 places. Left 3 places. That's my translation. What if it asks for the vertex of my parabola? I'm going to look at my translation or look at this and figure out which one refers to the x and to the y. So the one that's telling me to go up and down would be my y. So that's negative 2. The one that's telling me to shift left to right would be the one inside this little parenthetical expression. And so that's telling me not a positive 3, I need the opposite of that, that's a negative 3. And that would be the vertex of my parabola. But as you move on, since life is just always challenging, you also have something different. So remember, if you've got a square, if something's being squared, moving all the way over here, if something's being squared, you're going to end up with this parabola. But if you look at the next thing that we're doing on page 347, that's not a parabola. That's a weird-looking crooked road thing. And what's happening to it? It's being cubed. So let's look at what the first thing is. If we have something that looks like this, very similar to a parabola, I'm just doing like a little graph, that's basically telling me, all right, I've got this curve going on. You have a much better curve that is, look on page 347. This is example 4. I've got this curve going on. And then I've got this little inflection. And that's telling me my inflection is going to be at the origin. Then you've got a couple of other translations of this point, of this weird looking S curve thingy. It's not even an S curve, it's a backwards S curve. It's I don't know. I don't know if I've ever seen exactly what they call that thing. But you've also got some other translations for that as well. So that's just telling me I've got this weird shifty thing going through an origin. Look at your next one they've got. Your next one looks like this. It's x minus 4, right? X minus 4 cubed. And then I'm adding, got an input and an output of a positive 5 that I'm adding to that. It's very, very similar to what we did with parabolas, okay? If I want a translation, if I want the translation to that, it shows me down here what's happening for the translation. So if I've got, my translation would be, is that I am going up 5 places. If you don't like places, if you want to be fancy, your book calls it units. But, I'm just kind of putting it in common terms. That's telling me not going to the left 4 places, but I'm doing the opposite. I'm going to the right 4 places. Right 4 places. Then what they're going to ask you about cubed functions is basically what is the point of inflection? I'm abbreviating point. What's the point of inflection? The point of inflection would be very similar to the vertex of a parabola. It's basically looking what's the x and what's the y. What's the point of the translation where it shifted? So, and this is pretty much saying, how did it shift right to left? How did it shift, no, this one's, sorry, right to left. How did it shift up and down? Sorry, when I'm looking at my watch, it's normally I'm getting a text. I'm just trying to make sure if it's important or not. How is it going up and down? So that's how we get the point of inflection. I'm going to curve this a little bit. So let's look. My x, how did it go right to left? It went to the right. That's positive 4. How did it go up and down? That's my y. That's 5. Understand that? They gave you another example that I'm going to let you look at yourself, because what I'd like for us to do is get started on some of your homework. While we're on this page, though, while you're on page 347, for your test and your quiz, you have to be able to just look at an expression that looks like this and be able, for both a parabola as well as a point of inflection, be able to look at that and tell me what is the translation as well as what might be the vertex or the point of inflection. So your quiz questions pretty much come from page 347, from either looking at that table, one of those 2 tables, being able to determine stuff. If you flip the page, we get started on homework. Remember, my homework says to do, I'm not sure what page my homework on. It says to do 1 through 49 odd, which we never go all the way through all the review. So basically it would be 1 through 33 odd. But what I'm going to do in your work today is we're going to actually do some that I have just highlighted so we can try to work on it and make sure you understand what you're doing. So turn over to your homework. Your homework starts on page 340. When is it? 348. I almost said 343, and I thought, that's not right. I'm going to go out of screen and erase this in case I want to shift over from one side to another. Let's get caught on my cord. So, let's look at your homework. First of all, your very first one, we just go to number 1. Are you all with me? Yeah, I'm making sure I'm still on screen. So on number 1, it's y equals x squared plus 5. What can I tell from this already? If I look at this, that's telling me, hey, it's squared. That's telling me it's a parabola. That's the shape I'm going to graph. And if it's basically asking me, if we read the instructions, describe the translations of the graph of y equals x squared or y equals x cubed that produce the graph of each function. So all it's asking me is what's the translation for it. So look, nothing's happening to the x in here. So nothing's shifting right to left. What is happening for a translation is it's going up 5 places. Now you don't have to do this, but I'm just going to reiterate it over and over to kind of get it in your brain. What would be the vertex of that parabola? So remember, that's me trying to find the x and the y of the vertex. Nothing's happening to this. Nothing. Or a big stinking 0. Nothing's happening to shift it right to left. But something's happening to make it go up and down. So that would be 5. So that's the vertex. You don't have to have that. I'm just trying to get it into your brain what we're doing. I'm just going to shift over here and let's do the next one. So let's look at the next one. The next one I'm going to do with you is number 5. I'm just trying to do a couple from each little section. So let's look at number 5. So number 5 looks like this one. It is y. You have a parenthetical expression, x minus 5 squared, and then plus 6. So if I'm looking for the translation for that, the translation is just me saying, how's it going up? How's it going down? That's telling me it's going up 6 places. This is telling me it's going to which way? Right or left? Right or left? That's telling me it's wanting to go to the positive side of the x, the opposite of that. So it's going to the right 5 places. If I was asked for the vertex for that, I would say it is 5 and 6. All right? So 5 and 6. 5 units right, 6 units up. Now I'm going to go on down to where it says state the coordinates of the vertex. We've been doing that on each one, but I just want you to really get this in your brain, maybe, because come on. I've been in your shoes too. Some of you, this is all you're going to do, so the more I can make you do while you're watching a video, then the more it might get in your brain. So let's look at number 9. Number 9 has f of x. Don't let that scare you. Remember, that's the same thing as saying y, okay? It's just a cooler way of saying it. F of x equals x minus 3. All of that is squared, and it's a plus 1. And now this one's not asking me for the translation. It's not asking me for going up 6 places, right 5 places. That's a translation. This one is asking me for the vertex or the point of inflection if it's a cubed function. So let's look at number 9. And that's me asking for the vertex. That's the up and down. This is the right to left. That 3 is telling me to go to the right 3 places. So that's a positive 3. That's telling me to go up and down on that y-axis 1 place. So that's your vertex for that parabola on number 9. Now let's look at a cubed function down here. I've circled 13. I think I'm just going to erase. I'm getting tired of moving. So let's look at 13. If we look at 13, I have a cubed function that's got f of x. And it is x cubed plus 19. And we all say, thank goodness I don't have to graph that because that would be a big mama graph. But there's not a parentheses here. Nothing's going on right there, which means the only thing that's happening here is this point of inflection, or this little weird backwards SE curve thing, is going up 19 places. That's it. Nothing's happening to x, or nothing's shifting right to left, so I'm just going to put a 0. And then I'm just going to say my y, though, is going to be shifting up the y-axis 19 places. Now, if we look at our next exercise, I'm moving to exercise B. Let's read the instructions, guys. Sometimes you can miss a whole thing if you don't read the instructions. Exercise B says state the coordinates of the vertex or the point of inflection and then create a table of at least 4 or more ordered pairs. Now on your on your quiz, you do have to do a graph. So that's why I was wanting to do at least one of these with you. So let's move a little closer to handy dandy graph paper, or Big Mama graph paper is what I always like to call it. Let's do the table first, and then we'll work on the other stuff. So what I can tell from, I'm doing 22 because you have a weird S with a point of inflection that you have to graph on your quiz. Let's look at this one. So 22, I have f of x, and that's equaling x cubed minus 2. So basically what's happening here, I could already be able to figure out kind of where, this is going to basically, my x, if I was looking at my vertex, my x is, or my point of inflection, nothing's happening to x, so it's going to be 0, but I do know at least one thing right here, and that's, this is going to shift down the y-axis 2 places. So if you wanted to go ahead and get that in your brain. Sometimes it's good to know what that vertex is or that point of inflection is, so I can try to figure out what points I want to use. So they do a little table like this. And then so to figure out y, I'm going to figure out some x's, and then to figure out y, I've got x cubed and minus 2. Since we're cubing here, you do not want to use like massive numbers because you don't want to make your graph really difficult. So you can kind of put right here in the middle. All right, that is a negative 2. I know that right in the middle, I'm going to have a point of inflection where it's 0 and negative 2. So the easiest thing to do is maybe just say negative 1, negative 2, and over here positive 1 and a positive 2. So I can just stay right in there and see what's happening. So let's think about what I'm doing. I'm going to fill out one for you so you can see. Technically what's happening there, you might like that other table. We've done another table that looks like where if you prefer this one, it's the same thing. It's just this is how my book set it up. But if you prefer this one, that's perfectly fine. Just remember you have 1 that's going to be a 0 and a negative 2. And then we're going to do negative 1, negative 2, 1, and 2. Either table that you prefer is fine. So I know that's kind of a weird shape there. But what's happening is basically this negative 1 is going in here for 3. So technically what's happening there is you have wait a second. Yeah, so I totally we'll just go with it since we've got it here. So if I have a negative 1 times a negative 1 times a negative 1, think about what's happening. Negative 1 times negative 1 would make it positive, then I have to multiply it to negative 1 more time, and it becomes negative. So that effectively is a negative 1, and then I'm subtracting a negative 2, which makes that a negative 3. Then, with the 2, think about what's happening with that. Most of y'all can cube 2 pretty quickly in your head. That's like 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So that would end up being a negative 8, right? A negative 8, and then I'm subtracting or adding the opposite, adding a negative 2 to that, so it becomes a negative 10. We already did this one, so don't worry about it. Then let's look at these two. If we look at these, and I'll go ahead and fill this in. I got a little bit off because the way I did that one. Let's look at these two right here. if I put a 1 in, 1 times 1 times 1, and then I have a -2, that's going to end up being subtracting. If I have a positive 1, subtracting 2, that's going to be a -1. Then here, 2 times 2 times 2, that's going to be an 8, but then I'm going to subtract the 2 and have a 6. Now we are going to graph this. So I'll go ahead and fill this out so maybe we can look at our things right here too. So that's going to be a -1, and this is just going to be a 6. So you can graph these however you want. Some people like to graph the point of inflection first. Some people do not, but you do it however you want to. I think I'm going to go ahead and graph. The first thing I'm going to do is graph the point of inflection. If you look at the point of inflection, we had it right here, and that's going to be where it's 0 and -2. So 0, and then I'm going to come down to a -2. Let me get a different marker. What are you doing? Maybe red. So this is Christmas colors on the graph today. Then I have a couple more points I'm going to put down. I have a -2 and a -10. So I'll start at the point of origin, or 0, 0. That's telling me to go to the left 2 places and then to go down 10 places, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm using 2 points on both sides. You need at least 1 on each side to be able to do a graph. I think on your quiz, it probably does ask you to make a table with at least 5 points or something very similar to what it asks. Yeah, to get at least 4 more ordered pairs, because that's just how to make it better. So our next one is I'm going to come to the left 1 place and then down 3 places. I'm going to start right here again. I'm going to the right 1, and then I'm going to go down 1. And you can start to see that weird shapy thing that's happening. I'm going to go to the right 2, and then I'm going to go up 6. 1, 2, 3, 4, 5, 6. And now we just got to connect the dots, which I'm not that good at, but hey, here we go. And whoops, okay. We have a weird swoopy thing. Yours is probably much better than mine. Try to be as neat as possible on your quiz. At least let me see all your points. Don't do the point. What I do not want to see is you, okay, here's my point of inflection, and there. You need exactly what it's asking for on the quiz. You need 4 points. You need that point of inflection, and then you need 2 points on this side and 2 points on the other side. There's one other thing I want to do with you in your homework, and I'm going to go to number 34. Number 34 is a question not on your test or your quiz, or sorry, not on your quiz. It is on your test. So let's look at 34. So 34 has a graph, and they want you to look at the graph and figure out what the formula is. So if we look at the graph, what you're trying to do is you're trying to figure out what this would be. And the way you figure that out is first you ask yourself, what is 34? I'm going to pick it up and show it to you. Of course, mine already shows you what the answer is, so I'm covering it. It's that right there. We're looking at this graph, 34. So I look at 34 and I ask myself, okay, what kind of shape do I have? That's not a parabola. That is a weird S-curve. So it's not going to be squared. It's going to be cubed. And then what I need to do is, okay, look at my point of inflection, or look at the point that's right here. If it's not right there, then that means something has made it shift up or down. Okay? If it's not, sometimes this one, it just shifted up and down, but the one you've got on your test, or sorry, the one that you have on your homework today has also shifted to the left and right as well. So this one has, just like this one, it's shifted up, it's shifted down, and it on the one on your homework has also shifted to the other side, which shifted right and left. So let's just start writing out what it would look like. So this is 34, and then we're going to try to figure out what it is. So it's going to be y equals, and since I know something shifted to the right and left, something's got to be right here. That's what I'm looking for. It's cubed. I know that because it's a weird S thing. It's not a, it's not a, and right now we don't know if it's plus or minus either. But it's not a weird S thing, so I know it's going to be cubed. So, and this is basically, I'm trying to figure out, did it go right or left? And here I'm going to try to figure out, did it go up or down? So those are the two things I'm trying to figure out. I'm looking at the point of inflection. That's where I get those two numbers. So I'm looking, it hits right at the vertex of a little square on the graph. And basically what I can tell is that point of inflection on that little graph on page 34, I could go ahead and just make what the x, and I could go ahead, it looks like, all right, my x was a -1, and then I shifted up 2 in order to get that point of inflection, so my y was a 2. So that was just looking at the x and the y. But now I have to stick that in here. So y equals x, okay, that's a -1, but I'd put the opposite of that in here. So that's a -1, so I'd be adding 1 in there. And then how did it go up and down? It went up. So since it went up, that is a +2. So my expression for that would look like this. Just to be able to determine what the point of inflection is, I figure out the point of inflection by looking at the graph, and then after I find it, I just stick it into this equation. So that describes to me that point of inflection. So that's all for today. If you have questions, you can leave questions in the comments below on YouTube if you wish, or since that's really public, you can message me in Facebook if you're looking at this from Facebook, or of course your parents can send me a text, and if we need to be able to set up a time where we can maybe get some we need to do Zoom potentially, or we can do FaceTime or something like that. I don't have everyone's. I have a few people who sent me their personal cell phone numbers so I could just send them a link. If you wish for me to do that, I know a lot of parents, what they're doing is they're just copying, or they're just forwarding the link from their phone to maybe your all's phone. But if you would prefer me to shift it to your phone, that's perfectly fine. Sometimes I prefer, because I've had a couple of parents who asked me to do that. So just send me, just text me. Your parents can, and with your contact info, and I don't mind to change that. Otherwise, you can always look at the YouTube channel, or you could go through the Facebook private group that we have set up for this class. So let's close in prayer. And Father, we just want to praise you and thank you for giving us the opportunity to take a time to learn about parabolas and points of inflection. And thank you for the sunshine you've given us, and thank you for your grace and your salvation. We love you in Jesus' name, amen. And guys, stay well, stay hydrated, make sure you get enough sleep. Love you.